Welcome to iTTV for Form 5 Physics. The title of this lesson, Electromagnetic Waves. In this lesson, we want to have a look at a series of waves called electromagnetic waves. Electromagnetic waves are made from electrical and magnetic waves that move at right angles to each other, and they transfer energy from one place to another. Electromagnetic waves include our radio waves, our microwaves, ultraviolet rays, gamma rays. Let's have a look at these electromagnetic waves. After rain in the afternoon, sometimes we can see rainbow in the sky. The rainbow of colors is made up of 7 visible lights. Visible lights are part of the electromagnetic spectrum. There are many other components of electromagnetic waves. 2 common electromagnetic waves. Visible light comes from a lamp in your house. Radio waves that come from a radio station. Other examples of electromagnetic waves: microwaves, infrared and ultraviolet light, X-rays and gamma rays. Visible light and X-rays are 2 very narrow regions of the spectrum. The diagram you see shows you the electromagnetic spectrum and all its components. Electromagnetic waves are continuous and exist from a big range of frequencies. This continuous range of frequencies is known as the electromagnetic spectrum. The longer wavelength regions are located on the far left of the spectrum, and the shorter wavelength regions are on the right. The electromagnetic waves on the left will have lowest frequency, and the right, the frequency is the highest. So this is our electromagnetic spectrum. We have 7 electromagnetic waves that we need to know. Let's sketch this up on the board. So if we start over here and move our way across the board, like so, we start off on the far right hand corner over here with our radio wave, which is then followed by microwave, which is then followed by infrared. This is followed by visible light, followed by ultraviolet, which we will just write down as UV. UV is followed by X-ray, and X-ray is followed by gamma rays. So this is our spectrum. Over here on the left hand side we have a long wavelength. So lambda is high. As we move across the spectrum, what we find that on this side, lambda is actually much smaller. So lambda becomes smaller as we go from left to right. Now, we know already from our relationships that if your wavelength is longer, your frequency will be shorter. So over here we have a lower frequency. Sorry, not a shorter frequency, a lower frequency. So here if lambda is high, F, the frequency, is low. As we move across to this side, as lambda becomes shorter, our wavelength is shorter, our frequency increases. So this is a gradual change that we get as we go from left to right. The frequency increases as the wavelength decreases. Other things that we need to know about our electromagnetic waves. They all move at the speed of light. all of them have the same speed, which is the speed of light. They are all transverse waves. And finally, they do not need a medium to propagate, meaning that all of these waves can travel in a vacuum. So it does not need a medium. And like all waves, they will transfer energy from one area to another area. Now we also need to sort of know roughly their wavelengths. The wavelength of visible light is approximately 10 to the minus -7 meters. As we move towards the right-hand side, our wavelengths increase roughly by a factor of 2 each time. So this is about 10 to the minus 5, roughly 10 to the minus 3, and over here roughly 10 to the minus 1. And as we go this way, it diminishes because our wavelength becomes shorter, and it's similar in terms that it's moving by a number of 2. So here it becomes roughly 10 to the minus 9, 10 to the minus 11, and 10 to the minus 13. Remember, all of these are in meters. So that's how our wavelengths change. This is an approximation, so please don't take this as a fixed number, but this is an approximate value for their wavelengths. Property of electromagnetic spectrum. The electrical and magnetic oscillations in an electromagnetic wave are at right angles to each other and to the direction in which the energy travels. Electromagnetic waves are transverse waves that transfer energy from one place to another. The oscillation of electromagnetic waves changes in electrical and magnetic fields. They carry energy along at right angles to the direction of the oscillations. That is why the family is called the electromagnetic spectrum. Energy carried by the waves depends on the wavelength. The shorter the wavelength, the more energy they will carry. High energy carried by electromagnetic wave cause more harm to living things. Can be transmitted and absorbed by matter and do not need medium to travel through. The speed of electromagnetic waves is 3 times 10 to the power 8 meters per second in a vacuum, which is the speed of light. As waves, electromagnetic waves can be superposed and produce interference effects. The propagation of electromagnetic waves obeys the law of reflection, refraction, and can be diffracted, which we've seen already. When we learned our lesson on diffraction, we saw that light could be diffracted. And when we did our lesson on Young's double slit experiment, we also studied how light interferes and produces bright and dark fringes. Now, as light is an electromagnetic spectrum component, this means the same applies to all the other wave types in the electromagnetic spectrum, meaning that they can all be reflected, refracted, or diffracted and create interference patterns. Let's try an exercise. How did electromagnetic waves get the name? So, why do we call them electromagnetic waves? Have you written down the answer? The oscillation of electromagnetic waves will change in electric and magnetic fields. Let's try another question. Which wave in the electromagnetic spectrum carries the most energy and is the most dangerous? Now, what we said earlier was that when the wavelength is shorter, the energy is greater, or the amount of energy being transferred is more. Now, our short wavelengths are on the right-hand side, meaning that it's these waves over on this side that carry more energy. So, what is your answer? Have you written it down? Let's compare. The shortest wavelength regions such as X-rays and gamma rays. Application of electromagnetic wave. In the diagram you see a satellite. Radio waves. This Boeing BSS 601 HP satellite is MEASAT 3, which is used as a communication satellite for Astro. The range of radio wavelengths is very wide, extending from about 1 centimeter to hundreds of kilometers. Information can be sent to other parts of the world. Microwaves. Repeaters are fixed to relay microwaves for handphones. Microwaves are useful in telecommunication. Radio links between satellites and ground stations usually use microwaves. Even our mobile phones use microwaves to transmit information. Microwaves have the shortest wavelength in the electromagnetic wave family, being typically a few centimeters. Microwaves are unable to pass through obstructions such as hills or buildings. Many fixed aerials are often mounted on hilltops and the roofs of high buildings. These aerials are used for amplifying and relaying microwave signals and are called repeaters. Radar systems. A radar system can detect any aircraft or missile from the enemy during a war. Use microwaves to find the direction and distance of objects, which reflect the microwaves back to a large receiving aerial mounted near the transmitter. Metal objects like ships, aircrafts and missiles form suitable reflectors of microwaves. Infrared light has a wavelength range of 0.7 micrometers to about 1 centimeter. Infrared radiation is invisible radiant heat energy from hot objects. The remote control to switch on and off the TV uses infrared. When an object is red hot, it emits red visible light as well as infrared radiation. When we warm ourselves near a fire, it is not the fire touches our hands. It is the invisible infrared radiation that will warm our hands. The remote control we use to switch on our electrical appliances such as the television are using a beam of infrared to direct to the sensor of the television. We do not need to walk to the television set to adjust the volume or change channels of the television broadcasting. Night vision. The picture shows two American soldiers pictured during the 2003 Iraq War. Heat sensing or infrared goggles. These show anything that emits normal heat radiation in the given area. Special photographic films, which are sensitive to infrared light, can take pictures in the dark without using a flashlight. These infrared photographs can be used to detect temperature differences in the region. The hottest part of an object emit more infrared radiation of higher frequency and have more effect on the film. Physics in medicine. Thermograph of a breast cancer patient. Thermography, also known as thermal imaging or infrared imaging, is a painless, non-invasive way of visualizing the body's heat patterns. It provides a color code and actual temperature data to show the temperature ranges. These photographs are called the thermographs, which are helpful to doctors to detect circulation of blood in arthritis and cancer cell where the skin is warmer. So, we've had a look at radio, microwave and infrared. What are their main uses? Well, if we go up here, our radio we tend to use for communication. So let's put that in here. This is used for communication. We notice that with microwaves, because the wavelength is slightly shorter, you get less refraction, which means that the waves travel in a more direct pattern. Also, microwaves can carry more information. So we use them in our satellite communication. Okay, satellite communication, and also we use it in our handphones. So our mobile communication. Down here we have our infrared. We said that the infrared is used for a variety of applications. We have remote controls, we have night vision, and also we have, as we said, thermographs, which basically allow us to visualize the heat that is emanating from a body of a patient. So these are some of the uses of radio, micro and infrared. Let's move on and have a look at the applications of the other electromagnetic waves. The visible light. Visible light and photography. The colors of the rainbow. Red has the longest wavelength and violet has the shortest wavelength. Visible light waves are reflected back to the eyes and we can see colors in nature. So basically, our visible light has one main function. This allows us to see. A secondary function is photography, which uses the light to create images, real images on film, which we can then basically use. X-ray and gamma rays. X-ray and gamma rays have higher frequency than ultraviolet light. They have higher energies, greater penetration power in matter, and thus greater danger to living cells. Gamma rays. Gamma rays, gamma photons, are emitted from the nucleus of some unstable radioactive atoms. Gamma-emitting radionuclides are the most widely used radiation sources. An advantage is that gamma rays penetrate many materials. They do not make them radioactive. The three most useful radionuclides are cobalt-60, cesium-137 and technetium-99. Cesium-137 used for cancer treatment. Cobalt-60 used to treat cancer and sterilize medical equipment in hospitals. Technetium-99, widely used radioactive isotope for diagnostic studies, for brain, bone, liver, spleen and kidney imaging, and also for blood flow studies. So these are the uses of our X-rays and gamma rays. So X-rays, we use these, of course we all know, to look at broken bones, etc. And gamma, well, we use it to treat cancer and we use it for imaging inside human body. Now our ultraviolet, well, this one is a bit odd. We don't have much use for it, although we do use it for sterilizing, because it kills bacteria, and we use it for testing for banknotes, so for testing notes. And this way we can check to see if a banknote is a real note or a counterfeit note. Let's try a few questions. State 4 types of waves found in the electromagnetic spectrum. We have 7 of them. List any 4 that you like. The 4 that you think that you will be most likely to remember. Have you listed them down? Answer: visible waves, radio waves, microwaves, X-rays. Any others that you said will also be taken, such as our ultraviolet or our gamma or our infrared. List 2 uses of electromagnetic waves in the fields of communication and in medical science. Any 2 uses. So think of them. We've got thermography for our infrared. We have cancer treatment, imaging, X-rays of broken bones. All of these are used in medical fields. Communication, we use our radio waves, our microwaves. Have you listed them down? Let's have a look at the answer. Answer: communication, radio and TV transmission, telecommunication. In the medical field, X-rays and gamma rays that kill cancer cells. Explain why a fluorescent lamp can emit more light than ordinary filament light bulbs. So, this is to do with the visible light that is being produced. Think about it. Have you written out an answer? Let's have a look at the answer. Energy is converted to light and not as heat as in filament bulbs. So in a fluorescent bulb or fluorescent light bulb, what we get is more visible light and less infrared radiation. But with a filament bulb, well, we get both of these being produced, which means the amount of light is less, therefore it is less bright. Summary: electromagnetic spectrum. Make sure you know all the waves in the spectrum. Make sure you know the gradual change in wavelength. Wavelength decreases. Make sure you know the gradual change in frequency. Frequency becomes higher. Make sure you know the common characteristics. They are all traveling at the speed of light, all transverse waves. They don't need a medium, and they transfer energy from one place to another. State that visible light is part of the electromagnetic spectrum. Right bang in the middle is our visible light. List sources of electromagnetic waves. So, how do we get these electromagnetic waves? Radio waves and microwaves can be produced by oscillating systems. Infrared comes from heat sources. Our X-rays and gamma rays, well, these comes from nuclei of radioactive particles. Properties of the electromagnetic waves. These are the key things: penetrating power, the amount of energy being transferred. And finally, applications of electromagnetic waves. It is very important that you know their applications, but it's also important that you know some of the harmful effects of these waves. Radio waves and microwaves can give you mental distress. Infrared can cause burning. Visible light, if it's too intense, can cause you to go blind. Ultraviolet can cause skin cancer, as can X-rays, which can cause cancer, and gamma rays, which can cause cancer and mutations. So not only know the applications, but also know the dangers of each of the electromagnetic waves. That's all the time we have for this lesson. Thank you for watching iTTV.